Here we have a table of values of x and y that pertains to this equation. And of course we have two values of y that are missing, and we need to complete that table. Complete the table by substituting the values of x into the equation. So we have x squared minus 2x minus 3, and we do not have the y value when x is equal to -1. So -1 squared minus 2 times -1 minus 3. Square -1, we get a +1. Negative multiplied by negative is positive, so we'll have 1 plus 2 is equal to 3. Then we minus 3, and that is equal to 0. And 0 goes right there. Do the same here, substituting 2. What do we know? Or what do we expect? Well, we expect the value to be -3 because we say 5, 5, 0, 0. And then -4 is in the middle, so we imagine that it could be -3 right there. Although on some occasions the CSEC examiners kinda cause one of the digits to be skewed, one of the values to be skewed, that when you calculate it, it is somewhat different from what you would expect in the table, which of course is a correct value, but they try to make sure that the students or the candidates will not be able to just look at it and tell what the value is. But I realize that in recent years it is more predictable than in former years. So we put a 2 here into this equation. 2 squared minus 2 times 2 minus 3. So square 2, we get 4. Then we have a -4 here, so that's a 0, and then minus 3 is equal to -3. And of course we put the -3 right there, and the table is now complete. Let us draw the graph of the function. The scale will not be the same as in the statement of the problem. Consult the accompanying booklet and the presentation video for the correct scale. So we are not using the exact scale given to us in the examination. As a matter of fact, you will discover that these might not be exact 2 centimeters, or this as a single centimeter. So the graph is a very good representation of what we should have, but it might not be to the exact scale because this grid was designed on the computer and not from a graph paper. So let us plot that point. -2, 5. So -2, 5. -2 in the x direction, 5 in the y direction. -1, 0. -1 in the x direction, no movement at all in the y direction. The point will be right here, so we do not move again. 0, no y movement right there. Then what do we have? No x movement, -3 for the y, so 0, -3. So no x movement, but -3 for the y, so we have right there. What do we have next? 1, -4. 1 in the x direction and -4 in the y direction. 1, -4. The point will be right here. And then we have 2, -3. So go to 2 for the x and -3 for the y, and the point will be right there. What else? 3 for the x and no movement in the y direction. The point will be right here. Generally in a classroom situation, students get confused when they need to make use of a value of 0 as one of the x or y ordinates. Maybe they always want to go back to the origin when they see a 0, but they need to understand that we have 0 for the y, but the x movement is -1. Therefore, it cannot be at the origin, and also in these particular cases. Of course, I've seen graphs that pass through the origin, and no doubt the x and y ordinates will be equal to 0, both of them. But we can take a second look at the way that we plot the points for this graph and other graphs in arriving at the location, the correct location of a point when one of the ordinates is equal to 0. So there we have 4, 5. So 4 for the x and 5 for the y. What else do we do? Finish up by drawing the smooth curve through all of those points. What do we do next? We need to determine the value of y when x is equal to 3.5. So we locate 3.5 on the x-axis. Then draw a vertical line to meet the curve. But what are we really doing? We are actually finding where on the curve x is equal to 3.5. So actually x is equal to 3.5 right here on the x-axis. But the corresponding point on the curve, for the corresponding point on the curve, we need to go right there. There is where we will locate it. Right there. What do we do next? Draw a horizontal line to meet the y-axis and take note of the value of y. So there's our horizontal line. It goes straight across, and we are trying to determine the corresponding y value, and y is equal to 2.2 units. We have other things that we need to be able to determine by the use of that curve. The axis of symmetry is a line that divides the curve into halves that are mirror images of each other. Or we may say that it is the vertical line that passes through the extreme point, which is the maximum or minimum. In this particular case, it is a minimum. So it passes through the minimum point on the curve. So there we have our axis of symmetry going straight through the minimum point on the curve, and of course dividing the curve into halves that are mirror images of each other. No problem. X is equal to 1, so it passes through the value of x on the axis, the x-axis, where x is equal to 1. So x is equal to 1 is the equation of that axis of symmetry. Now we need to determine the minimum value of the expression or the function. The minimum value is the lowest point on the curve. It coincides with the axis of symmetry. The minimum is given relative to the y-axis. So there it is. The minimum point is right here, given relative to the y-axis. So the minimum value is y is equal to 4. Anything else? I'm sure, else we wouldn't have this large space right here. There we have an equation that we need to be able to solve without using the quadratic formula and without factorization, just to look at the graph and tell. The equation is saying that the function is equal to 0 or y is equal to 0. We have the entire expression is equal to 0. But in the equation, y is equal to x squared minus 2x minus 3. Therefore, y is equal to 0, and also x squared minus 2x minus 3 is equal to 0, because y is equal to x squared minus 2x minus 3. So in the equation that we have right here, we have somehow encrypted the statement that y is equal to 0. Y is equal to 0 on the x-axis. As a matter of fact, y is equal to 0 is the equation of the x-axis. Therefore, we need the values of x where the curve crosses the x-axis. Y is equal to 0 on the x-axis. Y is equal to 0 is the equation of the x-axis. So we need the points where the curve crosses the x-axis. As a matter of fact, the plural word values that we have in the statement of the problem indicates that there should be more than one of them. So where they are, here and there, so these are the two values where y is equal to 0, where the expression is equal to 0, where the expression crosses the x-axis, and we have -1 and a +3.